We're now going to introduce a second method for solving a triangle. This method is known as the law of cosines. The law of cosines says, given a triangle ABC, the following are all true. And we have three versions of the law of cosines. We'll come back and reference these formulas in a minute as we start our first example. The first example asks us to determine the three angles for a triangle in which side A is 3 inches, side B is 5 inches, and side C is 7 inches. So we're going to return to our formulas and pick one of the three formulas to get us started with this problem. We're going to use the first one, although you could actually use any of the three to begin the problem. So the first formula says a squared is equal to b squared plus c squared minus 2bc times cosine of angle A. And so what we're going to do is we're going to plug in the numbers that we are given in the problem in the corresponding places in the formula. So for a squared, we're going to enter 3 squared. For b squared, we'll enter 5 squared. For c squared, we'll enter 7 squared. Minus 2 times b, so 2 times 5, times c, c is 7, and then times cosine of angle A. We're going to do what simplifying we can, remembering that we take care of exponents first. So 3 squared is 9, 5 squared is 25, 7 squared is 49. Next we do multiplication. So 2 times 5 times 7 is going to give me 70. Then we do addition and subtraction. So we can add the 25 and the 49. Keep in mind that we cannot subtract the 70 because the 70 is attached to the cosine A, and so 70 cosine A cannot be combined with just a regular number. So I'm going to have 9 is equal to 74 minus 70 cosine A. Our goal now becomes to get the cosine A by itself. So the next thing that I'm going to do is subtract the 74 from both sides of the equation. And so 9 minus 74 is negative 65. And we have negative 70 cosine A. Again, our goal is to get cosine A by itself, and so we're going to divide by negative 70. Now, I'm not going to worry about reducing that fraction right now, but I am going to go ahead and cancel my negatives. So I have 65 over 70 is equal to cosine A. Now remember that when you are looking for an angle, you use the inverse feature of your calculator. So we're going to enter this into our calculator as inverse cosine 65 over 70. And what the calculator gives me is going to give me angle A. So make sure that your calculator is in terms of degrees. And then we're going to enter in inverse cosine 65 divided by 70. And you should get 21.79. And this is the degree measurement for angle A. Now, what we're going to do now, since we also need to find angle B and angle C, is we're going to select a second formula for law of cosines, and repeat the same steps. So I'm going to use the second one, the one that starts out b squared. And so our formula will look like b squared is equal to a squared plus c squared minus 2ac cosine b. And we'll plug in. So for b, we're going to plug in 5 and square it. For a, we'll plug in 3. For c, we'll plug in 7. Then minus 2 times 3 times 7 cosine b. Again, we'll do the exponents first. So 25 is equal to 9 plus 49 then we'll do our multiplication. So 2 times 3 times 7 is negative 42. We'll do our addition next. 9 plus 49 is going to be 58. Then we'll subtract the 58 from both sides. Again, your goal is to get the cosine b by itself. So we'll have negative 33 is equal to negative 42 cosine b. We'll then divide both sides by negative 42. And again, a negative on the top and a negative on the bottom will cancel, so we'll have 33 over 42 is equal to cosine b, which we will enter in our calculator as an inverse cosine of 33 over 42, and that should give us angle B. And so that gives me 38.21 degrees for angle B. Finally, we need to find angle C. Instead of doing another round of law of cosines, to find angle C, we'll simply use the fact that all three angles add up to 180. And so we're going to take 180, which is the total number of degrees in the triangle. We're going to subtract off 21.79, and we're going to subtract off 38.21. And the result will be angle C. So 180 minus 21.79 minus 38.21 gives me 120 degrees exactly for angle C. And that solves our triangle using law of cosines. We're going to look at one additional example. Okay, so our second example says, the course of a sailboat race instructs the sailors to head due east 11 kilometers to the first buoy. They are then to veer off to port to the left by 20 degrees and proceed for another 15 kilometers, at what point they should find the second buoy. What bearing would a sailor take to go from the starting point directly to the second buoy? And for this problem, they do give us a picture which helps us visualize the problem in more exact terms. So let's look at the problem one more time in terms of the picture. It says that the course of a sailboat race instructs the sailors to head due east 11 kilometers to the first buoy. So here's the starting point. We're going due east 11 kilometers to that first buoy. They are then to veer off to the port by 20 degrees and proceed for another 15 kilometers. All right, so they are going to make a 20-degree turn. Now, if they kept going straight, they would have gone this way, but instead they're going to make a 20-degree turn. and head in this direction. And they're going for 15 kilometers in that direction. The question asks, what bearing would a sailor take to go from the starting point directly to the second buoy? So in other words, going along this path instead, in what direction would he need to travel? So what we need to find is we need to find angle A. However, if you think about our options in terms of using law of sines or law of cosines, we don't actually have enough information to use either one to directly find angle A. One thing that I can do, however, is work on finding the length of side B. And I could do that by using law of cosines. So I'm going to try that first in hopes that that gives me a little bit more information that I can then use to find angle A. So I'm going to set up my law of cosines using my formula for b squared. So I'm going to use the 11 and the 15. Now, it doesn't actually matter which is which. Technically, I guess if angle A is here, then the 15 is going to be the A. And if this is A and this is B, then this would have been our angle C. So across from C, we would have 11. And then we'll have 2 times those same two numbers, 15 and 11. And then cosine of angle B. So we know that if we have 20 degrees on the outside, they've marked 160 on the inside for that obtuse angle. And that is the angle that is opposite side B that we're looking for. Okay, so let's go ahead and work this thing out. So 15 squared is going to be 225. 11 squared is going to be 121. 2 times 15 times 11 is going to be 330. The next step is to add the 225 and the 121. So that gives me 346. And then what is left can go in the calculator. So I am going to go to my calculator and I'm basically just going to enter the right-hand side in as it is, 346 minus 330 times cosine of 160. And that's going to give me 656.0985. And I'm going to take the square root of that. And that gives me side B to be 25.61. We'll do 2 decimal places, kilometers. Now that we have side B, we can actually use fairly easily law of sines to find angle A. So I'm going to set up one of my ratios with the A values. So I'm going to say sine of angle A over 15. And I'm going to use the B ratio, so sine of 160 over 25.61. We're going to cross multiply, which will give me 15 sine 160 is equal to 25.61 sine A. We'll then divide both sides by 25.61. And again, remember that if we're looking for an angle, we're going to be entering this in our calculator using an inverse sine. And so basically we're going to do the inverse sine of 15 sine 160 divided by 25.61. And that should give me angle A. And so when I enter that in my calculator, inverse sine 15 sine 160 divided by 25.61, that gives me an angle A of 11.56 degrees. And if you look at angle A, that angle is north of east. And so that is how we will describe that. That is that many degrees north of a straight east direction.